Hello, computer scientists, and welcome to week 9, day 1. I hope you have had a nice break and are ready to get going. We are going to jump right into MongoDB with Python. And I'm going to do a quick overview, and then we're going to install Thonny and connect to our MongoDB. So in general, there's a few different ways to connect to MongoDB, just like there were with MySQL. So you have the Mongo shell, which is just like typing MySQL in a command line. They're text-based interactions. So you have to, type in every command and you get a text result on every command. We're not really going to use that in this class, but you are welcome to play with it. It's a full JavaScript interpreter, so you can write JavaScript programs, and it's pretty cool. There's also a program you can download onto your own computer called Compass, and that is just like MySQL Workbench. So it's a standalone program that runs on your computer that connects to either a local MongoDB or a remote MongoDB. And so, yes, you can install MongoDB on your own computer if you'd like. There is a free version. Again, I think it's a great exercise, just like I suggested installing MySQL locally on your machine. I would suggest trying to install MongoDB locally on your machine. But you don't have to for this class. We're going to use a remote version. And then, of course, the third way you can connect is with a program, Python, Java, PHP, whatever. And so all of these connect to the MongoDB database process. So that is either on your machine, or what we are going to do is we are going to use Atlas, which is the cloud-based MongoDB database provided by MongoDB itself. So I do have a MongoDB instance running on the Mr. Bartu server, but it is, since it's free and easy to use Atlas and set up our own little cloud database individually, we're just going to go ahead and do that. So just a quick refresher of I guess it's not last week, it's several weeks ago. The terminology that you need to wrap your head around. A database is a database, so that's nice. It's the same thing that we're used to. But remember that MongoDB doesn't work the same way as MySQL. The idea is all your data that you're going to use is organized in the way you're going to use it. So if you, for example, have an article in a newspaper, all the information about that article is in one document. So the author, the text of the document, any comments on the article, all that information is stored in one document, because the idea of a MongoDB database is that the way you use your information should be the way you store it. So you can kind of think of a document as a row in a database, but really it's its own thing. And then a collection of documents is kind of like a table that has a bunch of rows in it, if you want to think of it that way. One of the biggest differences is obviously in MySQL, a row cannot have rows inside of it. It doesn't really make sense to think of it that way, but documents can have subdocuments. You can have, the perfect example, the news article, you can have documents inside that, one for every comment on the news article. And you don't know how many comments there will be in advance. And for that matter, every document could be different, even in the same collection. In MySQL, obviously every row has the same column headers. But in MongoDB, every document could be different in the same collection. It's just a bunch of information stuck together. So Compass is the way we're going to navigate around our database. It's similar to phpMyAdmin. So when I say compass, that's what I'm talking about. Everything in MongoDB is stored in JavaScript object notation, so it's really similar to Python dictionaries, coincidentally, where you have your key over here, you have whatever the key of the data is, and then you have the data itself. And inside the data, you can have keys and data, so you can have subdocuments or objects, really. You can have lists, so you can have basically any kind of data you want, but the types we use are strings, so that's Apple reported fourth quarter. Numbers, they don't have quotation marks around them, it's just a number, 1132. Boolean, has this article been published, true or false? You'll notice it also doesn't have quotation marks around it. You can have arrays, so square brackets, electronics, computers, blah, 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 blah. And you can have objects, so like this author is the key, and the data is an object inside it with key and data, key and data. And even inside those, you could have, another object with keys inside it. So there's, some information here at the bottom, json.org, and there's a link to some more information if you want to learn more about the data types in MongoDB. But, of course, nothing is as it seems, because text is pretty slow. We want everything to be binary. So we're not, under the covers, we're not actually using JSON to send stuff around. We're using something called bson, which is just binary JSON. So, as you can imagine, text is not great for storing high precision numbers, dates, actual binary data like images, and videos and stuff like that. So behind the scenes, when you are communicating with your Mongo database, everything is going to be converted to binary to do the communication. It's just a lot faster. When you do searches, binary is obviously a lot faster than trying to do text-based searches. The storage is more efficient. Again, we're not going to get into bson and how it works and everything, but if you want more information, there's a link. But you should know that the data going back and forth is in binary format. It's not in text format. So what we're going to do today is we're going to write a little Python program, and you're going to use a library called PyMongo, which thankfully has already been written for us, to connect to the MongoDB database in the cloud. So we're going to install Python. I have step-by-step instructions listed in the assignment, and I'm going to go through it in this video, but for now, if you don't watch the rest of this video, feel free to do it on your own. You're going to download from thani.org. You're going to install for Windows or Mac, depending on whatever you want. There are a couple options. Mostly you can accept the defaults. And then once it's installed, you need to install these two libraries. So you're going to go into the Tools menu, click on Manage Packages, and then you need to install PyMongo and DNS Python. Like I said, I'm going to go through this later in the video, so if you don't feel comfortable, it's in the step-by-step instructions and in this video later on. How do we connect? Once you have the libraries installed, you literally need 2 lines of code. You need import PyMongo, the library that we're going to use, and then you create a client with a username and password. So it's just as simple as connecting to MySQL. If you have MongoDB running on your machine, you can also connect locally and you can actually watch it connect. It's pretty cool. But we're going to use Atlas for our purposes this year. Yeah, so this is the Java connection to Python. I am not going to mandate that you use Python, but if you want to use Java, you can sure do that. I'm not going to do that. So these are the step-by-step instructions I referenced. I'm obviously posting this video and the slides and the step-by-step instructions in the assignment as usual. And I am going to now go through creating a MongoDB database and connecting to it with Python. There is an assignment in GitHub Classroom, so if you are comfortable doing all that on your own, you can exit the video now and go crazy. Otherwise, let's get going. All right, so here I am in mongodb.com/cloud/atlas. Again, there's a link in the instructions, and it comes up with this. You can just Google it too. What we're going to do is we're actually going to use Google to sign in. I highly recommend that so that you do not have to create another username and password and remember it and blah, 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 blah. Let's just go ahead and click sign in. And then we're going to click the blue Login with Google button. It will ask you if you want to accept the name, email address, language preference, profile picture, blah, 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 but that's not a whole lot of information to share, so I'm okay with it. And it will create an account for us, and I would recommend always reading privacy policy and terms of service, but I'm not going to make you do that in this video. And it will create an account for us, and we no longer have to remember a username and password for this site. We can always just click login with Google. All right, so we're going to create a new organization. You can call it whatever you want. I'm going to call it CS485. You want to choose MongoDB Atlas because it offers us a whole bunch of information. And I already am a member since I'm logged in and I'm the organization owner. I just created the organization. And since for now we're just going to be doing individual projects, you don't need to add any more members. So we're just going to use our own organization owner for now. So don't have any projects yet because I just created the account. So I'm going to create a new project. I'm going to call it MongoDB CS485 project number 1. Oh, can't call it number 1, project 1. All right, so now I can go ahead and create the project. And you can see up here in the top left, I've created MongoDB CS485 project 1. But of course, I do not have any clusters. So a cluster is as we talked about a few weeks ago, MongoDB is very scalable. So a cluster is a set of servers that is running your database. We only need one server in our cluster, but we're going to create a cluster anyway because that's what hosts our database. We do not want to pay for anything, so we are going to select the free version over here. We're going to create a free cluster. It doesn't really matter what provider we use. I'm just going to select the default Amazon Web Services in North Virginia. As far as we're concerned, they're all the same because we're just going to be using MongoDB. I do not want to upgrade to a dedicated cluster because, again, I don't want to pay, so I'm going to continue without upgrading. And you can see it says, we are deploying your changes. So it's going to take a few minutes, so I am going to pause the video. All right, so now we have our cluster set up. That should have only taken a couple minutes, hopefully, for you. And so the first thing we need to do is set up a connection. So we're going to click this connect button. So in the real world, we would want to only whitelist certain IP addresses so that only certain people could connect to our database. However, since you're probably going to be working from home and school and a coffee shop, well, I guess not right now, but in theory, um, and we don't really care if people actually see our data, we are going to just authorize any IP address because I don't want you to get frustrated trying to remember to always add IP addresses if you change where you're working. So we're going to add a different IP address. We're just going to add 0.0.0.0, which means anywhere. And in the description, we'll type anywhere. And so now we have basically any IP address will work. And now we need to create a user in our database. So this is different than the user of this website, which you already created by clicking login with Google. This is the database user itself. So I'm just going to create one called Mr. Bartus, and I'm going to create a password without special characters for now because that'll make my life easier later. You can add special characters and you can always come back later and add special characters, but when we use our Python program to connect, we're going to have to URL encode our special characters, right? If you have like a star or a exclamation mark or anything like that, we're going to have to use the % for it in our connection string. And that's where a lot of students get hung up. So for now, even though we wouldn't do this in the real world, I would just use a password that doesn't have any special characters in it. So we are ready to connect, and we have to choose a connection method. We are going to connect with an application. We are going to use Python 3.6 or later, and this is our connection string. So we're going to use this once we've installed Python. So you can copy it somewhere now if you want, or I'll show you how to come back here. But for now, we're going to close it because what we need to do is we need to actually create some data. We could go through the steps of creating our own database and everything like that, but just for ease of use, we are going to use some pre-made data that MongoDB will create for us. So back in the main clusters area, we want to create some sample data. So right here on these little dots, inside that menu, you're going to see an option that says Load Sample Dataset. So we're going to click that. It's a little bit big, so it's going to take a few minutes to create it. So again, I'm going to pause the video and I'll come back when it is loaded. So once the data set is loaded, you should be able to go into the collections and see the 7 databases that it has created for us. So there's a bunch of data in here you can see. So this is Compass that I mentioned earlier. You can see all the stuff in here. Each one of these is a document. And each one of these is a entry in that document. So you can see there's text, there's date, there's numbers, there's objects. So all the data types that we talked about. And feel free to browse all the different ones. There's, geospatial, weather data, stuff like that. So now we're going to use Python to connect to the Airbnb database and look at some data. So the first thing we have to do is download Thonny. So we're going to go to thonny.org and we're going to select whichever one works for our system. I'm on a Mac, so I'm going to download for Mac. Going to click on the package to install it. All right, so once it is successfully installed, go ahead and run it, and you'll see kind of a blank slate here. The nice thing about Thonny is it has a virtual environment inside it. So we don't have to worry about installing packages into our computer environment. we can do it all from within Thonny, which is really nice. So go ahead and click on Tools, Manage Packages, and you will see a window like this pop up. The two libraries that we need to install are PyMongo. So click Find Package and then click Install. And the other library that we're going to need is called DNS Python, because we are going to use it. We're using MongoDB over the web. So we're going to install that one as well. All right, so we have those installed, and those will just work for us now. At this time, you should clone your assignment from GitHub Classroom. I can't do that because I'm not a student in the classroom, but hopefully you know how to do that by now. And you can pause the video while you do that. And then we're going to open up the Python script inside it. So the script that it comes with your GitHub assignment is called MongoDB test.py, and it should look remarkably like this. And if you change your connection string in here to your own connection string, it should just work. So go back to your cluster here. So go back to your clusters here, and this time you want to click on the connect your application, and make sure that you select Python 3.6 or later. So this is our connection string. You're going to copy this. You're going to go back into Thonny, and you're going to put it in here. So the password here is obviously not your password. You are going to put in whatever your password is. My example was MongoDB, and you're going to run it, and it should return one row. So the way this program works is it creates a client from the PyMongo library, creates a client. It looks for this database, Airbnb, that's in our cluster. So it sets this database object equal to this database. From within this database, it looks for the collection called listing and reviews and puts it in this variable called my collection. And from within this collection, we're calling the function find1 with the name equal to White House. And then we just print out that document. So if we go back into the database called Airbnb listings and reviews, and we look for name White House, right? We can see there is only one result. The name here is White House, and here's all the stuff that's associated with it. So if we go into Thonny and we click on the result, you can see these are all the data that it got back from the database. And that's it. Obviously, there's a lot of different find commands. So if you just want to retrieve all of the data, you could just say find, and then you would have to, it's a list. It returns a list now. So you'd say for my document in my documents. Right? I just called it my documents. Print my document. So this is going to return everything. So that's like thousands. So if you run this, it's going to return a whole lot of stuff, and you probably want to stop it after a while. But yeah, you can do lots of fancy searching. You can look for name. You can look for all sorts of different stuff. any of the fields. So now you have the connection, you have the basics of how to find a document. So for the assignment, I would like you to create a document, find a document, update a document, all the things that are listed in the assignment. Make sure you commit it and push it into GitHub from the GitHub Classroom assignment, and you will receive a perfect grade. If you have any questions, please email me or hit me up on Discord, and I will get back to you as soon as I can. Thanks.